15. So our next unit is all on linear relations. It's split into like 2 bigger chapters within your workbook. So the first section is called characteristics of linear relations, which is where we're starting. I don't know why they split it into 2 parts. It's really one like unit together. Some of this unit, or a good portion of this unit, is already covered from your science classes, so from physics. So today should be, in theory, all review from your science classes. Who's your science teacher? Mr. Dice. Okay. I'm more familiar with how Ms. Egley runs it, so hopefully they're fairly similar, but nonetheless, it should be all covered in your science class. I talked to them. They've already told me they've covered this. So we'll see how much you actually remember. So slope. Who knows what slope is?
Like a little bit.
Okay, let's hear your little bit, Gavin.
I know there's a line and then you draw a box under it. And that's somehow slope.
We draw a triangle.
Yeah.
So right here on the page, there's some lines. Let's look at the AB line. So we draw a triangle below it. And make it a right triangle, yes? And this is rise over run. Good. So slope is like defined as our rise over our run. Slope is an incredibly useful thing. And throughout this unit, and even more so in physics, you're going to learn more and more about how useful slope is. There's different types of slope. So there's a positive slope, a negative slope, zero slope, and a slope where we would actually say it's undefined. When slope is running up and towards the right, so oops, I meant to highlight that, we call it a positive slope. Have we discussed this, positive and negative slopes? Okay. That's a positive slope. This is a positive slope. There's also negative slopes. So let's go and calculate the slope of point AB. All you're doing is literally counting the boxes. We would call the boxes like our units. So going upwards, I have literally a distance of 2 units. So our rise for line AB would be 2. Count the run. Let's all make sure we can count. Let's start off with, can we count? Count the run. What did we get? 7. Good. So then our run is 7. So our slope is rise over run, or 2 over 7. Generally speaking, leave your slope as a fraction. It's more helpful. But if it's like a nice number, like 1/2, you could put it as 0.5. We'll get more into that later on. CD. So counting our slope for line CD, draw your right triangle. Could I draw my triangle like I did in red there? But you also could draw it like I did in blue. Are the values going to still be the same though? Yeah. Yes, good. Let's try counting again. Count your rise and count your run for CD. When you're counting it, you want to remember a positive count would be to the right or up. A negative count is going to be to the left, right? Just like how our like number lines work, or down. So if you're counting it using like the red triangle, I'm going to count to the right 5. Is that correct? No, 4. 1, 2, 3, 4. Yeah, my run is 4, my rise is 5. But if I was counting the other one, like in blue, I'm going to the left 4. So I would say it's -4. And then I'm going to go down 5. So it would be -5. So depending how you count it, your signs may change. However, notice if I use my blue example, My rise was -5 because I went down. My run was -4 because I went to the left. But when I do that division, what's a negative divided by a negative? Good. So it doesn't matter how you counted it, as long as you're consistent, right? Both of those values were negative in blue, so my overall became a positive. If you counted the red version of it, they were both positives, so your answer is still positive. At the end of the day, my slope, regardless of which way I did it, is still 5/4. So you have to be careful with that. EF, you're going to notice one's going to be positive and one's going to be negative. So when I draw out my triangle, depending how you're counting. So if I decide to count, let's do our rise first, but I'm going to count a downward rise. That's 1, 2, 3, 4, 5. I'm going to have a -5 count because I counted downwards. Then I'm going to count to the right, 1, 2, 3. So that's a +3 because it's going to the right. So in our little table, I'm going to have a -5 over +3. So overall, that gives me a negative run. Sorry, a negative slope. Okay, turn your page. On this line, I'm just going to talk about this. I'm not going to fill it in because I think this should be fairly obvious. So overall, we have an entire straight line here, right? They've broken it down into segments, we would call it, like point A to B and C to D. That's the same line overall, right? Therefore, my slope is the same overall. So it doesn't matter where you count your slope, like where you were to draw your little triangles. They've drawn a couple for you. But at the end of the day, like if I use that triangle or that triangle or that triangle, I'm still going to get the same slope overall because my fractions will just reduce down to the same number. So I want you to pick a row on this like table and fill in one. Don't all just fill in the first one. And then you can see that our slopes will all be the same in the end. So count as much as you can. How did they count this? Like count, you'd count like your spaces between two dots as like 1. When you figure it out, you should, no matter what, if you can count and reduce fractions, you're going to get 2/3 for a slope. You always leave a fraction in lowest form. So we're always going to get 2/3. Right? And that like should logically make some sense, right? Like it's the same line, it should have the same slope no matter what 2 points I pick. Is that okay? Does that make sense? So 2/3 slope. You can have slopes that are fractions, like a decimal. That means it's like a fairly shallow slope, but you can also have slopes of like 10, where it's a whole number as well. Okay, let's look at these examples down here. Looking at this first example of AB, this line, I'm just going to darken it a little bit. Do I have a change in my rise? No. I have a change in my run though, right? So my line's getting longer and longer. So if I was to draw a little triangle here, I can't. right? Because there's not a vertical distance to it. So that means my rise in all of these, there is no rise because they're all straight horizontal lines. 0 divided by anything is always what? 0, right? So the run exists though. So I'm going to have 0 over some number. Right? In some cases, it's going to be 4. In some cases, it's 2 here. But at the end of the day, 0 divided by anything is going to be 0 for our slope. So a horizontal line has a slope of 0. Okay, let's take that logic over to a vertical line. Is there a change in my rise? Yeah. Yes. Is there a change in my run? No. So my run in a vertical line, so my rise is going to be a number. It exists. It's something. It's changing. But my run is 0. It's not changing. Can I divide by 0? Can I divide by 0? Please tell me you guys know this. No, so we say this has a slope that's undefined. So a vertical line turn your page. So we're going to make some kind of generalizations on this page. I like thinking of it almost even more general than what they're saying. Have we all skied or snowboarded before? Yes? Okay. So I like to remember our slopes with like a skiing analogy. As you're going up your ski lift, so you're going up your chairlift, like this, right? Here's my little chairlift, here's my guy. We're going upwards our hill. As you're going up the chairlift, going to like about to go skiing, about to do your first run, are you happy or sad? You're not scared. Let's not talk about being scared. You're happy, you're excited. So your slope in this direction is positive. You're excited to go skiing, right? Once you get to the top of the chairlift, let's say you're a snowboarder, what do you have to do first? Good. So then you have to like sit down on the ground and you're buckling in. So then you have your like emotions are neutral, or you would have a 0 slope as you're buckling in, right? Because it's painful and a boring process. Then you start skiing. You go down a black diamond and you're terrified. Screaming. So then that's a negative slope in that direction. Say then you hit, what is it, a tree well? Your emotions are all over the place, so then you're undefined. So this is like a general trend of your slopes. So positive, you're always going in that direction from left to right, moving upward as you go up your chairlift. 0 is our horizontal slope line. Negative is you're terrified going down a black diamond, and then you fall off a cliff and die and you're undefined. Gavin.
Is that how you actually experience skiing? Because then what's the point of skiing? Like if you're going down and you have negative emotions, then like why would you there?
It makes the right on the chairlift.
Well, I'm saying it's like, it's just let me have my analogy. Because I'm just trying to help you here, Gavin. So, grid 1, all those slopes are what then? Grid 1. Look at here. Grid 1, the left. Positive. All of these are positive. They're going up the chairlift on all of these. They're all also going left to right. Going upwards. We're going up our chairlift. We're excited to go skiing. We're not scared yet. Grid 2 are all negative slopes because we're scared as we're doing the run. So it's too hard of a run for us, black diamonds, whatever it might be. So we have negative emotions as we're going down the hill. That's all this one's getting at. So at the very bottom, a line which rises left to right has a positive slope. A line which falls left to right has a negative slope. I think my chairlift analogy is more fun though. Okay, we're going to skip class example 2 because I don't think it's printed very well. So class example 3, draw a line segment which passes through the points -4 and 2 and has a slope of -2 and 3. So we're given a couple things here. First off, let's do a quick review. Coordinates are always written X and then Y. So let's all plot this correctly, this point that we're given at -4 and 2. We're told we have a slope of -2/3. We have a negative slope then, so we're going downwards. So if you were plotting this, you can actually just count it out. So remember, our slope is rise over run. So that means we're going down by 2, and then we're going to go right 3. So when I count this out and I plot these points, if I count 1, 2 down, I'm going to like put like a tiny little dot here to kind of hold my place. Then to the right 3. 1, 2, 3. So my first coordinate is going to be at like -1 and 0. Has a difference of 2 here downwards, and then we went 3 to the right. I can do that again. So 1, 2 down, and then 3 to the right. 1, 2, 3. Which gives us a second point at 2 and -2. Go ahead, Andy. What? Sorry, say that again. Oh, you could just continue this for as long as you wanted. That's all. No, it wanted 3 sets of coordinates though. Go ahead, Gavin. So I could also interpret this with the negative on my 3. So you could also think of it as going up 2 and then 3 to the left. So I'm going to go back to my original blue point, and if I count upwards 2 and then 3 to the left, I could have a point over here. That's still in that same line. So that's a -7 and +4. So you can go in either direction with this, is what I'm getting at. Our next question, a line segment has a slope of -5/7 and a rise of 12. Calculate the run as an exact value. Whenever questions say exact value, that means leave it as a fraction. A reduced fraction always. So we know our formula is slope equals rise over run. So I'm going to plug in what I know here. I know our slope is -7/5. Remember that negative can go anywhere. So like -5/7, you could put your negative out front. You could put it with the 5, or you could put it with the 7. They're all the same thing at the end of the day. So we know our rise is 12. We need to isolate and solve for our run. So this is kind of like trig when we were solving for like our hypotenuse, where it's in our denominators. There's a few different ways you can do this one. I'm going to do it like the most algebraic way. I would multiply both sides by our run. So now it's going to be run times negative 5 over 7 equals 12. Multiply both sides by 7, cancels out 7 in my denominator. Twelve times 7 is 84. Then I would divide both sides by negative 5. Does 5 go into 84 a whole number of times? No, so you can just leave it like this. You can leave it improper. Don't worry about converting it to mixed. Go ahead, Gavin. No. And it drives me bonkers that in middle school, we preach and preach to always convert it to mixed. And then from there on, we're like, leave improper. Why? I don't know. Alberta curriculum. I know. Like a whole number with a fraction. Okay, we're going to do lessons 5 and 6 as well today, but these are the questions I want you to do. I've labeled them with levels just for like curiosity's sake. But that's what the questions you're going to do. So just circle those ones. And then we'll go on to lesson 5. So like number 1, you're going to pick 2. Number 2. No, you only have to like fill in 2 slopes. Like only do 2 rows. Don't do them all. So for like number 1, just do the first 2 rows of the table. Correct. Or 3. That was lesson 4. Yeah. No. We're going to do lesson 5 next. And then 6. You. What? We started on lesson 4. So none of your pages matched up with what I was saying? Gavin, how did you not put that together? Okay, lesson 5. So page 529. Actually, I take that back. We're going to go right to 530. Turn the page. Well, we are, but starting on the second page. So page 530. Have you seen the slope formula before? No. Okay. So for what we call the slope with the letter M. So M, we use M because an S often looks like the number 5 and people have very messy printing and that causes for confusion. So M represents your slope, just like L represents your length, right? We're just talking about an equation. So this is your equation, y2 minus y1 over x2 minus x1. That seems really complicated. It's not. All you're doing is you're going to pick 2 points, like on your graph. You're going to subtract the y values, which is the top. So your y coordinates. And then you subtract the x coordinates. So instead of counting your graph, you can do it with the coordinates. So you subtract your 2 y's and you subtract your 2 x's. So they gave us an example, number 1 here. Ignore how they wrote this out. They are making it difficult. So you would do like y minus y over x minus x. The most important thing that you don't mess up, this, like your y2, x2, is one set of coordinates. Your x1 and xy1 are your second set. So vertically, they have to match up. So when you plug in your coordinates, I suggest you plug them in vertically to help yourself out. So for example, if I'm using G as my first one, 8 represents my y value. -3 represents my x value. So I'm going to put 8 here, -3 here. We are going to have lots of integers at play, so be careful with negatives. Then my second set of coordinates are -2 for my y and 7 for my x. So then I have -2 and 7. Gavin, let me just go through this one and then I'll answer your question. So 8 minus -2, I have two negatives side by side, so that becomes addition. So 8 plus 2 is 10. -3 minus 7 gives me -10. 10 divided by -10 gives us overall -1. So between those 2 points on my graph, the slope would be -1. That's all it's getting at. Go ahead.
How do we know which points to pick?
They will be given.
Oh, well, then why do you say pick?
Well, like I could just give you a line and then you would have to pick 2 points from that line.
Oh, okay.
Yeah. Like in this question specifically, they gave you 2 coordinates, but you might have to choose what your 2 sets of coordinates are. Yeah. Any of them on your line. That's what I mean. Don't overcomplicate this. Okay, so let's look at this example. Eleanor, Bonnie, and Carl are calculating slope of a line segment. So that just means it ends. It's not a continuous line with arrows. Our points are 15 and 8 and -10 and 6. Their work is shown below. They got different answers. So they're making mistakes. So when you go through it, make sure that they're matching vertically. So 15 and 8 should go together vertically. So that looks good on Eleanor's. 15 and 8 match vertically also on Carl's. But where should the 15 be and where should the 8 be?
On the other side.
8. 8 is our y. So 8 needs to be on the numerator. So that's good with Carl. 8 should have been up top for Eleanor, because our y values are in the top. So then let's check with F. So -10 and 6 match up. 6 is our y, and 6 was up top, so that's also good. However, notice, so we have 8 minus 6, which is good, 15 minus 10. The mistake here is it should be 15 minus -10. Right, that coordinate on our F is a -10. So if I subtract -10, what do we get? 25. So this one should actually be 2 over 25. So all 3 of them are wrong. So see how what Bonnie did, she had laid out her denominator correctly. That portion was right, but she flip-flopped the 6 and the 8. So there's a lot of places to make some really small errors here. Yep. Yep. Collinear is a term that we don't use a lot in like the Alberta curriculum, but all it means is the points are on the same line. So points that lie on the same line are said to be collinear. So for example, those 3 points are all on the same line. It's a fancy way of saying they're on the same line. I don't know why they do it that way. So let's look at this example here. So consider these 3 points. Prove that the points A, B, and C are collinear. So prove that they're on the same line. If they're on the same line, they have the same slope. So we're going to do our slope twice. So let's do the slope first. Slope is defined by m of points A and B. So might be helpful, first draw like your division line with your two subtraction signs, so that way you don't forget to write down a negative if you happen to, like, if you're a person that forgets things often. Myself, I always do. So for point A, -3 is my numerator, and then 5 is my denominator because it's y first, x new denominator. For point B, it's going to be 6 and then 2. So we're making sure that vertically our coordinates are together. -3 minus 6 gives us what? -9. 5 minus 2 gives us 3. -9 divided by 3 gives us a slope overall of -3. So if these 3 points are all in a straight line, we have the same slope. So let's look at B and C now. So 6 for point B is my y, and then 2 is my x. For C, 33 is my y, and then -7 is my x. Go ahead, Camden. Whatever works for you. So if you're someone to make mistakes with it, put brackets. 6 minus 33, what does that give us? Good, -27. 2 minus -7. So 2 negatives side by side. Good, makes addition. So 2 plus 7 gives us 9. -27 divided by 9 gives us -3. So they have the same slope, so therefore they're collinear. So you can also use this equation backwards. So find the value of y if point D is also on this line segment. So right now we know somewhere we have a slope of a line that's like this. My slope overall is -3. They're plopping this point D in the middle. We don't know the y coordinate of it, but we can isolate and solve. So when we write out our equation, so we have m is equal to y minus y over x minus x. In this case, my slope is -3, so I can substitute that in. We don't know y, so I'm going to leave y there. I know the x coordinate, though, is -4. What can I do for my other x and y? Good, so we can use our points from before. So it's on line segment AC, so as long as I pick one of those points, I'm good. So let's use A. So I'm going to put -3, because that was the coordinates of A. A are at just 5 and -3. So now we need to actually solve this question, isolate and solve for y. So let's clean this up a little bit to make our life a little bit easier. So I have -3 is going to equal y plus 3 over -9. What's my first step in isolating to solve for y? Good, we have to get rid of that division first. I'm going to times both sides by a -9. So I get positive 27 is equal to y plus 3. How do I get y by itself? Good, it's -3. So y is equal to 24. Okay, these are the questions here. This next one is super, super simple. Because we would have half an hour left then of class, right? We go to 11:22. Okay. So lesson 6, we used to do an investigation on lesson 6. We aren't anymore. And so you guys were last week? Yes, Gavin. You don't have work time right now. No. So we used to do an investigation on this next one. Like we were talking about last week, investigations can be tricky if you know the information. This is one that often we were finding kids knew, as well as it was really simple. What makes something parallel? What makes two lines parallel? Good. They're on the same plane, so they're going in the same direction. We are going, I'm going to kind of like do my own thing here. So ignore what it's saying. On this first grid, so on lesson 6, we're on page 537. Wyatt, you with us? I want you to draw 2 lines to the best of your ability that would be parallel. Anywhere on this first grid. 2 parallel lines, so as straight as you possibly can. I get that you don't have a ruler. Doesn't matter. I would fill the space. Like, don't make them tiny. No, just 2 lines. Don't make this more difficult. So if this was my first line. That's a line. Well, no matter what, it's going to have a slope. If you drew 2 horizontal lines, that's the slope of 0. That's fine. 2 vertical lines, undefined slope. Yes, their slope is undefined. That's your answer. Okay, looking at my 2 lines. Yes, Calvin.
When you retrieve well, wouldn't you like die? So wouldn't that mean your like emotion level is 0 and not undefined?
I'm just trying to help you remember. It's not perfect. It's the best I've come up with. Okay, I have 2 lines here. Your 2 lines may look slightly differently. These 2 lines are parallel. Spell parallel correctly. What do you notice about the slope of these 2 lines? It shouldn't matter. In general, what do you notice about the slope of these 2 lines? They have the same slope. Do your 2 lines have the same slope? Yes, good. If I were to draw 2 parallel lines that were both vertical, are their slopes still the same? Okay. If I was to draw 2 lines that were horizontal, are their slopes still the same? That was part 1 of the investigation. So what's the rule here? Good, let's write that down. Parallel lines have the same slope. That's it. So for example, my red lines would have a slope of 1, 2, 3, 4, 5, 6, 7, 16. These would have a slope of 16, what did I say, over 6, so I can reduce that to 8/3. My blue lines would have a slope of 0. My green lines would both have a slope of undefined. Your lines are slightly different than mine, but they both have that same slope, is what I'm getting at. Parallel lines have the same slope. Yes, Gavin.
What's the highest mark someone has ever gotten on an investigation that wasn't this?
I've given 8 lots.
What?
Yeah.
I thought they had a few.
Okay. Yes. Yes.
Okay, so if we write an S instead of an M, is that like off? Like,
Yes. Yes. You also just won't. As more comes to this unit, you just won't. Okay, the second one. What does it mean for 2 lines to be perpendicular? Good, they T. What? Oh. Say it, say it. Good. So perpendicular lines on the second grid on that same page.
Where's the 90-degree line?
There isn't. Does your page look like mine?
Yeah.
Yeah.
So like, what is he talking about with his 90 degree?
He's answering my question.
What's the question?
Perpendicular lines cross
I don't even know.
at a 90-degree angle.
What is a perpendicular?
So for example, these 2 lines would cross at 90 degrees, so we would describe them as perpendicular. That's it. No, just Camden maybe should.
No, it's because I don't know what it is because I took French now. So the French.
Well, that's a fair excuse. That's a good excuse. Okay, I want you to calculate the height, the slope of line AB for me. So the line that's on your paper, figure out the slope.
Wait, wouldn't they have the same slope also?
No.
Oh, but negative.
Figure out the slope of this line. That's not how you describe slope.
Nice one. Okay, great.
I'm just saying right now, what's the slope of this line? Which we reduced to? Okay, remember, so rise over run. My rise went downwards, so it was -3 down and then 6 to the right. So my slope of this line is -1/2. We're going down the hill, we're terrified as we're skiing. So a negative slope of 1/2. Is that okay? Potentially? Okay, we're gonna draw another line. So you're gonna have a point here at, what is that, 0 and 2. And you're gonna have a point here, and what's that at 1? At -2 and -2. Those 2 lines are perpendicular. Calculate the slope of my red line. It is not the same. If it was the same, they would be parallel. Calculate the slope. Okay, so my rise over my run, it rised 4 and went to the right 2. What is 4 divided by 2? 2 over 1. Good. Did I say it wrong? We went up. We went to the right 2 and we went up 4. Okay, what do you notice about -1/2 compared to 2 over 1? So I want you to take a second right now. So this is the trickier part of that investigation. Compare, don't shout it out. I want everyone to have a second. So compare -1/2 versus 2 over 1. So before we compared slopes and we're like, oh, they're both 2. Oh, they're both 0. We're like, oh, they're same. how could you describe the like transfer from -1/2 to 2/1? I want you to take a minute. I want everyone to think about this. Don't worry about being like mathy, but just in simple terms, what changed and how did it change? This is like an investigation right now. So we're practicing. We're going to have more this year. So if we're practicing for an investigation, let's use our skills. What's common and what's different between these two slopes? Charlotte. Good. So I had a 1 here, and then I got a 1 there. What else is common? What else do we notice? Andy. Good. A 2 is here, a 2 is here. One's negative and one's positive. So our sign changed. So positive versus negative changed. The math term for like moving my numerator to my denominator is the numbers are reciprocated. On an investigation, do I expect you to remember the word reciprocated? No. You can describe my numerator moved to the denominator and vice versa. That's just fine. That's the rule for perpendicular slopes. The math way of saying this, you would say the slopes are negative reciprocals. Okay, turn to page 539, so we're skipping one page. They write this difficult, but the lines of parallel, if lines are parallel, they have the same slope. If the lines are perpendicular, the slope is the negative reciprocal. Ignore how they otherwise wrote it. I feel like that overcomplicates it. So we're going to go through these couple class examples, and then I'm done talking. So consider the line segment AC, and it has a slope of 3/4. If the line is parallel to that, it would have the same slope. So a line parallel, GH, the sides call it, parallel to AC would have a slope also of 3/4. If I draw two vertical lines like that, that means parallel. Versus if you draw it like that, that means perpendicular. So write the slope that would be perpendicular to AC. So a perpendicular slope, I'm going to flip my fraction, so it's going to come 4/3, and I change my sign to negative. So example 2, the slopes of two lines are given. Determine if the lines are parallel, perpendicular, or neither. So 1/4 versus 3/12. Is 3/12 reduced? No. If I reduce it, divide both by 3, I get 1/4. They have the same slope, which means what are the lines? Parallel. So like on my Cartesian plane, both lines are going to have like fairly shallow slopes, like that. 5/7 versus 14/10. So let's reduce that 14/10. Both are divisible by 2, so I get 7/5. Are those parallel, perpendicular, or neither? Good. So it's missing the negative. So for it to be perpendicular, it would have needed to be what? Good, negative. So if P is a point and Q is another point, find the slope of the line segment. So we have 2 points. Really helpful sometimes grade 10s to do like a quick sketch of a graph to help you visualize this. So 4/7, I'm going to have a point there, let's say. 6 and -2, so it's further to the right, but in the negative. It's my other points over there. Overall, is this slope going to be positive or negative? Negative, right? We're going down the ski hill. We're scared as we go down. A slope, so we want to find another line that would be parallel to this. So really, we're just finding out the slope. So when we do that, draw your line, put your 2 subtractions in, and then make sure we're matching it vertically. So 4 and 7. 7 goes on the top, 4 on the bottom. Y is our numerator, X is the denominator. For point Q, we have -2 and 6. 7 minus -2 gives me a +9 over -2. 9 over 2 is the negative slope that we should have expected, so that's good. A parallel line segment to that is going to have that exact same slope. Versus a perpendicular, so for it to be a perpendicular slope, my sign is going to switch to a positive, and I flip my fraction, so then it becomes positive 2/9. Turn your page. We have a triangle. Then it says use slopes to show that our triangle is right angled at point L. So let's start by sketching this image. So -4 and 2. I'm doing this very much as a sketch. It's just that visual aid to kind of help us out. M is at -2 and 7. And N is at 1 and 0. So this is my triangle. If right here is 90 degrees, we should be getting that perpendicular slope. So we need to actually figure out 2 slopes here, right? We need to figure out LM slope and LN. And then we're going to look at those 2 slopes. If they're perpendicular, it's a right triangle. If not, it's just not. So start off, let's write down our formula. So our 2 subtraction signs. Let's do point L first. It doesn't actually matter the order you do your 2 points. Like I could have done M first. So Y is my numerator, -4 my denominator. 7 in my numerator, -2 in the denominator. 2 minus 7 gives us -5. -4 plus 2 still gives us a negative, but only 2. Negative divided by negative gives us a positive 5/2. So for our second line, we're using L and N. So L, my y is 2 and -4. But now I'm going to use a different coordinate. So I'm going to go 0 and 1. Two minus 0 is 2. -4 minus 1 is -5. Are these negative reciprocals? Yes. So what's that mean? Good. So that means they're perpendicular. So therefore, it's a right triangle. This next question currently is a level 7-8. Would you guys like to try it on your own? So two lines have slopes of -3/4 and k/5. Find the value of k. So that's pretty unfamiliar. It's kind of vague, which is like our favorite situations for level 7-8s. Parallel lines, what do we know? They're the same. So let's set it up as -3/4 then has to be equal to k/5. Solve that on your own. Isolate and solve for k. You all should be able to do this. All you're doing is multiplying both sides by 5. What's scary here is your answer is a fraction. That's okay, right? We're talking about a coordinate, we're talking about a slope, we can totally have a decimal there, but it's something you haven't seen before, which makes us like uncomfortable, it makes you second guess. Camden.
Okay, so I end up in 15 on 20.
You only multiply the numerator.
Okay, what if it was 5 on k and you only multiply?
Then you would divide both sides. Yeah, so then it would be -3/20. Yeah. Charlotte. Well, really what I'm doing is multiplying both sides by 5/1. So I'm going like 5 times the -3 and then 1 times 4. You're multiplying the side by it.
5/1 times -3/4 minus 15/4.
Yes.
Yeah, and then equals k, right?
Yes.
And then to get that out of the fraction,
No, you just leave it.
6 is not 15/4 equals k.
Yeah.
Can't you just make it -60 equals k?
How is -60 the same thing as 15/4?
Where do you get 60 from? Because you multiply.
15 times 4 is 60.
Yeah.
But why? Why are you multiplying those two?
It's not a fraction.
But -60 is not equal to 15/4.
That equals 15 times 4.
It is, but that's not 15 divided by 4. Like you're just choosing to do extra math.
You can't just multiply both sides by 4.
Okay, if I multiply both sides by 4, I get -15 equals 4k, which we don't care what 4k is. You can have a fraction as an answer. My moral of the story. Okay, perpendicular is a little bit trickier. So for it to be perpendicular, they have to be negative reciprocals of each other. Correct? Yeah? Yeah? So what that means is if I have what would a slope that's a reciprocal of -3/4 be equal to? What's a negative reciprocal of that? Charlotte? good. So if I find a slope that's perpendicular to that, it would be 4/3. I made it positive and I flipped it. So this 4/3 slope is perpendicular already. So then if k over 5 would be equal to it because we already made it perpendicular. So we flipped the one already, we made it positive, so then I know my second line is going to have an equal slope to that. Charlotte? So -3/4 is perpendicular to 4/3. Do you agree with that? Yes. So then we know that k over 5 is going to then be parallel to 4/3 is what we're saying right now. So we've like put it into two parts. So it's like I took this first line. So -3/4 is going to have a slope like this. A line perpendicular to that is going to be like this, right? So then I'm just saying this k over 5 line also is going to be, oh my goodness, is also going to be like a line like this then. The 5's right here. So I've just said, I found a line that's perpendicular to our original of the -4/3, which gave us the 4/3. So now we're finding another line that is going to match that basically. So we do this one, we're going to do the same process from here, like we did on the previous one. Go ahead, Camden.
How come when you make it perpendicular, you switch the negative, like, -3/4 to +4/3?
Because the rule of perpendicular is it's a different sign and then it's flipped. So it's a negative reciprocal. So that just means your sign changes, right? To change the direction.
Is there a word for a different sign?
We say it's negative reciprocal. That's the word. So your sign changes and then you flip it is all to make it perpendicular.
Positive
No.
reciprocal? So like if you have 4/3.
You could, that would just be reciprocating it, but that's not giving you a perpendicular line.
So if we had 4/3 and have to make it perpendicular, then it would be -3/4.
So I'm just saying is I made my line perpendicular. That's where the 4/3 came from. And now I'm going to find what k is equal to because we know this k line is equal to this perpendicular one. So just like on the previous one, I'm going to times both sides by 5. So those 5's cancel out. Times by 5, 4 times 5 is 20. So then k would be 20/3. You have 2 minutes. That one's hard. You're really applying it separately. You're not dismissed. Sit down.
Oh no, I'm stretching, like I was sitting for like an hour.
Okay, I want for homework the questions from lessons 4 and 5 for Tuesday. Yeah. No. You're just having some homework.
Miss Stephanie, you are blatantly contradicting the wellness steps.
Yeah.
Am I?
You are in
Okay.
violation of my wellness.
So you don't want your test marks right away then?
No.
No? I said wait a couple weeks.
You can mark it literally at the end. I will
No,
know.
I would care. I need to know, right?
There will be questions for lesson 6, but I won't assign them. So just 4 and 5 for homework, please. Have a lovely long weekend.
No.